Hi, welcome back to Design Sparks. I'm Sara, and in this video we're going to see how to create an interactive map in Unity. We will import the model of an office from Revit to Unity, and we will create this interactive map, which will allow us to see the model from above, and then by clicking on some buttons on the interface, we will be able to zoom in on some of the rooms of the 3D model. This will allow us to create an interactive totem for the office's visitors, or we could use this type of presentation as a project presentation for a client. Let's begin. Let's start with some links. On the website arctoolkit.com, we have the plugin for Revit and the plugin for Unity. In the description box, you can find the other scripts that we're going to use for the creation of this map. As usual, we'll start from a Revit file. We have AT-Sync installed, so in the Add-ins tab, there is the button for the synchronization in Revit. So the first step is to launch the synchronization, and we speed up this process. At this point, we have to install the plugins AT-Sync and the AT-Explorer and the file that's in the description box, and just launch the synchronization of the project that we just exported from Revit. Now that the Revit project has been imported, we'll select the main camera and add the script Orbit Camera, which is one of the two scripts in the downloaded package. We'll add it to the main camera. And this component allows us to orbit around an object. We'll select the root object of the 3D model that we imported, and now if we press play, we can already see that the camera is moving around the 3D model. While still on play, we can modify the Orbit Camera component to set the proper parameters to orbit around our office. Once we're happy with the parameters, we can save them by going in the component. Here we need to select Copy Component, exit Play Mode, and select Paste Component Values. We have to do this because any change that we make in the scene while it's on play doesn't get saved. Now it's time to take care of the lighting of the scene, but we'll speed up this process. We'll add some reflection probes to improve the reflections of the glass in the office. We'll modify the skybox, set the right parameters to the progressive light mapper, and then bake. Now that the global illumination bake is done, we can check the final result by pressing play. Let's move on to the user interface. The UI gets placed into the scene through an object, a canvas object. And right-clicking on hierarchy, we can create a new canvas tag object by selecting UI and then canvas. We need to set the right parameters for the UI and then set the scene view to 2D. As first object of the canvas, we will insert an empty game object that will act as a container for our buttons. We want the buttons to be left aligned and vertically centered. So we will create this game object container and insert the anchor position values so that this object will always be anchored to the left side of the screen. At this point, we can create our buttons inside the container. Let's create the first one and duplicate it with Ctrl D, and then set the vertical layout group parameters to align them precisely inside the container. Now we're going to create some cubes that will serve as targets for the camera whenever we click on a button. Basically, what we want is, when we click on a button, we'll change the target of the camera from the root of the project to the cube that's linked to that button. So we can zoom in on the respective office. This is where the second script in the description comes into play. We must add it by selecting all three of the buttons, and then for each of them, we need to modify the target. For button 1, we'll set cube 1. For button 2, we'll set the cube of office 2. And the third button will be a back button, which will get us back to the overall view. So we'll set for it the root of the model that we imported from Revit. We must attribute the same max distance values of the main camera to the back button. And then we need to set a proper value to zoom in on the cubes. In this case, the ideal value is a 5-meter distance from the office, but you can set whichever value you want. Now we can press play and see what happens. We can see the buttons are on the left side, but if we click on them, nothing happens. The reason is because we need to add the corresponding action to the click on the buttons. So for each button, we'll head over to the button component, drag the button and select Switch Target, the component that we just added, by choosing the switch function. This must be done for all the buttons. We'll add onClick, select the button and choose Switch. Same thing here, click, we drag the button, select the component Switch Target and the function Switch. In this way, we have connected the click on the buttons to the switch component. So now we can move around the map, and when we click on a button, we can zoom in on the office. We can add as many buttons and targets as we want. The last step is to export this project, so we'll create an application now. With the application, anyone, even those who do not have Unity on their device, will be able to open the output of our project. Just need to set a few parameters, choose a folder for the export, and click Build. Here we are, the output of our project has been created. Now we have our application with a 3D model with working buttons that allow us to zoom in on the details of the model itself. So this is it, we're done for this video. As always, you can find all the info you need to recreate this type of presentation in the description box below. Let us know in the comments if you were able to work it out, if you had problems, or if you have any suggestion. Remember to subscribe to Design Spark so you won't miss any of the next videos. Until next time, bye bye!